All right, so for today's lesson, we're going to do it a little differently. We'll be working with the graph paper so that we can actually create our own arrays. So instead of having the array on the board, we're going to make our own. The first operation we're going to be working with is multiplication. Again, just like we talked about the last couple days, how the word of stands for multiplication. We can go ahead and put a little number 1 over here, like we've been doing with our notes. And the first problem we're going to be working on is 6 times 10. Now that seems like a pretty straightforward and easy multiplication problem, but again, we're using arrays. So if we're going to make a 6 by 10 array, what does that actually mean? Yeah, Jose.
We're going to draw 6 down and then 10 across.
Absolutely. Jose said 6 down, 10 across. So let's do it right next to it. We'll go 6 down.
Oh my god, it was going slow.
And 10 across.
Oh, this is oh. Oh.
And this is 6 by 10.
I thought we were supposed to do the circles. Like the
Nope, just like this. And then sure enough, we should have 6 rows of 10 or 10 rows of 6. Fifty-five, 56, 57, 58, 59, 60. All right. So you guys really impressed me yesterday with the way that you took that jump from working with fractions on the array to actually creating your own arrays within the array and working on actually creating algebraic expressions with that as well. But the next jump is to do things like this and to see that 6 times 10 is the same as a 6 by 10 array. So this should be pretty straightforward. We'll just move right on to the next one. Let's skip a line and we'll put a number 2. Number 2 is a 12 by 5, or 12 times 5. Just like when you were in like 3rd grade and you learned about multiplication, we can look at this one of 6 times 10 and say, oh yeah, look, there's 10 groups of 6 or 6 groups of 10 going this way. And it all makes sense. So using the array is not anything different than you've done before. It's just presented in a little bit of a different way. 12 by 5.
12 down,
12 down, 5 across. Now, if I wanted to save room on my paper, could I go 5 down, 12 across?
Yeah.
How come?
It's the same thing. The same thing, it's just reverse.
It's the same thing, it's just reversed. Now, here's the $1,000,000 question. And by $1 million, I mean you will get nothing. Does anybody know the name for that? The name of that property, where with a multiplication problem, it doesn't matter which order you put them in. The answer will be the same, like 12 times 5 is the same as 5 times 12. Vince, do you know?
They say 12 times 5 because they meant there's 12 up and then 5 across. That's why they put it different number before 5.
Vince says commutative property. Eddie agrees. Charlie agrees. Frankie agrees. Okay. Yeah, the commutative property means that wherever you move, you can move those multiplication problems around. Commutative property multiplication says you're going to get the same answer. 12 times 5, 5 times 12, same thing. 6 times 10, 10 times 6, same thing. So just to save some room on my paper, I'm going to go 12 across and 5 down. Oops. Ha.
Why does it glitch out, Mr. Cooper?
What's that?
Why does it glitch?
You know, I was messing with it yesterday. The students are commenting that the document camera that I'm also using is glitching out and making things look like in slow motion. I was messing with the wiring and the settings yesterday, trying to figure out how I could get it to record from the actual document camera. And it will record to this little SDC card, but the SDC card is not very big, and it doesn't have any sound. There's no microphone on it, which is why I've got my phone rubber banded to the top of it. So this is a 5 by 12, or a 12 by 5. And here is another interesting question. Ooh, I did it right. Okay. So here's a question I have for you guys. What is 12 times 5? Raise your hand. Kathy. 60. Now, here's a question I have for you, Kathy. How did you know that 12 times... Oh, I'm going to wait for these boys over here. Kathy, how did you know that 12 times 5 was 60? Excellent answer, Kathy says. I learned it in 3rd grade and I never forgot it. Yeah, I'm kind of the same way. Sometimes these numbers get a little bit bigger, though. Did anybody else maybe not remember what 12 times 5 was for 3rd grade and had to figure it out? Well, here's something interesting. When I have 2-digit numbers or 3-digit numbers and stuff, and sometimes I don't remember, like Kathy, because my brain isn't as great as hers, is I'll do something like this. Has anybody ever done something like this before, where they go, oh, I'll take the small number, and I'll go to the tens place, like 5 times 10 is 50, and 5 times 2 is 10, and 50 plus 2 is 60. Oh, Diego does that. All right. And Andres does that sometimes too? And Ricardo has used that strategy before. Do any of you guys who do that regularly, do you know what that's actually called? There's another property that's called. That's called the distributive property, where you're actually distributing the 5 to the different places and then creating another problem. I guess we could put some answers on here too, huh? 6 times 10, 60. 12 times 5, 60. Adrian has a question. Are they all going to be 60? Let's find out.
No.
The next one is... $24 times 2.5. Now Frankie, he's dishing out spoilers over here because he's already doing what we were talking about in that last one. He already started distributing
12 plus 24 plus 24.
Those numbers.
Which way do we do it? 24 across or 24 down? How are you going to do a half? Half the square?
This is great. This is great. I'm getting questions. I'm getting some people thinking. How are we going to do a half? How are we going to do this? This has just got way complicated. How am I going to make a 24 by 2.5 thing on my thing? What am I going to do? Well, I've got this for you. I'll wait while you guys discuss. Let's break this down. Now, as I was listening to Frankie talk with his group, he was like, oh, well, we're going to take the 24 and I'm going to multiply it by the 2. And then I'm going to take the 24 and I'm going to multiply it by the half, and I'm going to see what I get like that, and then I can put them together. Maybe I can show that with an array, or multiple arrays, just like you guys were doing yesterday.
Mr. Cooper?
Yeah.
Well, you see how 24 times 2 equals 48, and then if you do a half times 24 equals 24 over 48. No, it's 12.
I like it. Let's see if we can show that visually. How could I make an array? How could I make a box of 24? Let's just start with the 24. What could I do to make a box that has 24 little squares in it? Mariella? We could just count the squares, but I betcha you guys know some factors of 24 that are close to each other that we can make a nice good rectangle with. Adrian.
6 times 4.
Adrian says a 6 times 4 or a 6 by 4 box. I love that idea. That's exactly what I'm going to do. I'm going to start right here underneath it. I'm going to go 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4 across. Okay. Now I've got a 6 by 4. That's 24.
It equals 12.
Now, how many of those do I need? I'm multiplying 24 by 2.5. How many of these 24 boxes do I need?
2.5.
I need 2.5 of them. So right next to it, I'm going to make another one. I'm actually going to put 2 boxes in between. And I'm going to make another 6 by 4, just like Adrian said, so that I know that there are 24 in there. 6 by 4. And then I need, so I've got 2 24s, but I also need a half of 24. Raise your hand, how can I do that? What's that array going to look like?
It's going to be like 12 and 3.
Jose?
4 down and 3 across.
4 down and 3 across, I can do that. So I'll take 4 down.
I made half of a square, and then I made it made plus 2 of those. Yeah. I did my. Do we do wait, what's that? It's a 4 by 3.
And this is a 4 by 3. Yes. That's totally fine. That's awesome. So just like Ricardo and just like Andres and just like Diego volunteered earlier, sometimes when they have a multiplication problem, they'll take and they'll distribute those factors of 5 and they'll multiply it by the tens place and then multiply it by the ones place. We're doing the same kind of thing. Instead of trying to figure out these mixed numbers, we're going to take it step by step. Just like Monday and Tuesday, we were thinking like, well, what is half of 24? Well, you didn't have any problem figuring that out. Half of 24, we're just going to cut our array in half, and then we've got it. You did the same thing here. You found out you needed 2 24s, and then you needed a half of a 24. So we can just combine those together, right? 6 by 4, how many were in here? 24, right? And a 24, right? And then, how many are in this little one? How many are in this 4 by 3? 12, thank you. So 24 plus 24 plus 12, what is the answer to the problem? 48 times 2.5. Nathan?
52.
Check again.
60.
24 and 24
51.
and 12.
It's 60. 60.
Do we agree 60?
Yes.
Yes.
Okay.
Everything's 60.
24 plus 24 is?
24.
It's 48 plus
48
12 equals 60.
plus 12 is 60, right? We put the 2 and make it 50, and then the 10 and make it 60. That's all right. We're looking at it in a different way. So some of those things that are like automatic, maybe you're looking a little different. So it's okay. All right. Let's go on to the next one. This is going to be number... Ooh, am I going to have room for this one?
Yes, we can make it fit.
Yeah, let's make it fit. I hope. This is going to be 8 times 30.
Oh, we can do 8 down and 30. No, we can do 8 down, 30. We can do 100.
8 times 30. Now, this is another one with whole numbers. So, we're probably going to need to go... How should we build this box?
8 down, 3.
Yeah, I hope we have enough room. Let's see. 1.
No, 4 times 3. 4 times 3 equals 12, and then add a 0 on the 30. I have enough space.
We have just enough room if I start like way over here at the edge.
I'm going to do 4, 15, and then do another 4.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Just barely enough.
We have 4 times 15.
1, 2, 3, 4, 5, 6, 7, 8. All right. That's an 8 by 30 right there.
It barely fits.
So let's get this all set.
What I didn't do. It doesn't fit. I'm going to bring it on. Look at I'm going to finish it. I'm going to use orange now. Let's put it very bottom. You didn't use one. Yeah.
I can take you those somewhere distance.
Woo! All right. So we've got that all set up. Shh, shh, shh. And we'll do some operations with that tomorrow.